So today we are looking at doing a few more examples from what we did in class on Wednesday. I'm sorry that I couldn't be in class today. I am at a conference. Um, so I recorded videos for you so that if you want, you can go back and rewatch them, and also so that you're still hearing things the same way that I teach them in the classroom. You have your handout that you can follow. So that way you're not trying to just keep up with the notes and you can just follow with what's happening. So we're looking at number 5. I'm not sure that I covered both examples in number 5, and these are coming from your handout that you got on Wednesday from 4.1 with the simple and compound interest. So these are starting out on number 5 here. And I've got them all typed out on your sheet in case you did not bring your handouts with you. So when we're looking at finding the accumulated value of $5,000 for 4 years at 8% compounded continuously, then what we need to do is look at what do we have and what are we trying to find. So the easiest way to do these is to look at what do we have. So our 5,000 is going to be our P. So we have P is equal to 5,000. Our 4 years, that is going to be our T, so T equals 4. 8%, that's going to be our rate. Remember, you need to write it in a decimal form, so it'll be 0.08. And we're talking about compounded continuously. With compounded continuously, that tells us we are going to use the PERT formula. So we are actually going to use A is equal to P E to the RT. And we're just going to plug in our values. So P is 5,000. So this will equal 5,000 times E to the R of 0.08 times T, which is 4. You can plug that all into your calculator, and you will get $6,885.64. So that would be your final answer. On the next example, on number 6, we are finding the present value of $40,000 due in 4 years at 6% compounded semi-annually. So we are looking for the present value of what the value is now. So we are looking at what all are we given in our equation or our problem. So 40,000 is going to be our P. So P is equal to 40,000. And 4 years is going to be our T. So T equals 4. 6% is going to be our rate. So R is equal to 0.06. And compounded semi-annually, that tells us N is equal to 2. So find the present value of 40,000. So that's actually going to be our accumulated value. It's going to be 40,000. Find the present value of 40,000 that's due in 4 years. So in 4 years, that 40,000 will be due, and that will be our accumulated value. We need to find the present value. So that is going to be our principal. That's what we're looking for to find. So looking at the formulas that we have available to us so far, we are going to be using our A equals P times 1 plus R over N raised to the NT. And we're going to just plug in our values. So that's going to get us a 40,000 over here is equal to P times 1 plus 0.06 over N, which is 2, raised to the 2 times 4. So we need to solve for P in this case, so we are going to divide by everything that is not P. So we're going to divide by the 1 plus 0.06 over 2, raised to the 2 times 4. I'm going to go ahead and shrink that down to 8. We're going to do the same thing on this side. So 1 plus 0.06 divided by 2 raised to the 8. So everything on this side will cancel. So P, our P, is going to be equal to 40,000 divided by 1 plus 0.06 divided by 2 raised to the 8th power. When you plug that into your calculator, you are going to get $31,576.37. So the present value is going to be $31,576.37. And in 4 years, being compounded semi-annually at 6%, we will actually reach that $40,000 mark. Our next problem that we're looking at is going to be number 7. We are looking to find the interest rate needed for an investment of $5,000 to grow to an amount of $6,000 in 3 years if compounded continuously. So in this case, we are looking to see what we have. So we are given, find the interest rate needed for an investment of $5,000. So P is going to be equal to $5,000 to grow to an amount of $6,000. That's going to be your accumulated value. It's going to be $6,000. And we have T, which is equal to 3. And we need to find what R is. We do not know what our R equals. So we're going to, because we're compounded continuously, we will use our A equal to PE to the RT. So the accumulated value of 6,000 equals 5,000 times E to the R times 3, which is our T. So we're going to solve this like we've solved several problems. And first thing we're going to do is we're going to divide by that 5,000. So I'm going to divide both sides by 5,000. And we've talked many times in class about how if we have zeros that line up, we can reduce that down. So that'll get us 6/5 is equal to E. I can change the order here and make that to 3R. Now that I have 6/5 equal to 3R, we are looking to take the natural log of both sides because we need to clear out that E. So it's going to get us the natural log of 6/5 is equal to the natural log of E to the 3R. So that will get us the ln of 6/5 is equal to 3R. All we have left to do is divide both sides by 3. So that tells us that our R is equal to the natural log of 6/5 divided by 3. And we could put that into our calculator and get approximately 0.06077. And because this is a rate, if we want to get it to a percentage, we can move our decimal place over 2. So that'll tell us that it's going to be approximately 6.0, we can round that one up to an 8. The reason, because we're looking at a percent. Since we're looking for the interest rate, usually if we're putting it in the formula, we're going to have it in decimal form like that. But if we're actually looking to put it, what would the rate be? It's going to be 6.08%. The next problem that we're looking at is example number 8. And with number 8, we have a little bit that we need to cover on our handout about the effective interest rate. The annual rate adjusted for the number of times is compounded. This is the formula that we will use to solve number 8. So for number 8, we have find the effective interest rate of 8% compounded monthly. So if we're looking at using our formula, we have the R of EFF, so that's effect, is equal to 1 plus r over n raised to the n minus 1. So there's a few things that we need to know from our problem here. We know we have an interest rate, which is going to be our r. Our r is equal to 0.08. We're compounded monthly. That's going to be the number of times, so n will equal 12. So in this case, we want to find the effective interest rate. This will equal 1 plus 0.08 over 12 raised to the 12 minus 1. We'll put that in a calculator and we will get 0.082999. So then that tells us that this will become equal to, when we, just like we did up here, this will equal 8.3%.